Hey everyone, welcome to Rev Games Academy. In this video, we'll be exploring the basic game development workflow in Unity. Whether you're brand new to game development or aiming to refine your process, this is the perfect place to start. Let's jump right in. The first step in game development is planning your game before opening Unity. Decide on the type of game you want to create, whether it's an action-packed adventure or a relaxing puzzle game. Consider how players will interact with the game, what they will do, and what makes it enjoyable. Keep your target audience in mind. Designing for children might mean focusing on colorful and simple elements, while hardcore gamers may prefer challenging levels and complex mechanics. Think about the visual style of the game, whether it will be realistic, cartoonish, or uniquely stylized. Outline these ideas as your blueprint. Additionally, determine the platforms for your games, such as PC, mobile, or VR, as this decision will influence the development process moving forward. The next step is creating a game design document, GDD, which serves as the ultimate plan for your game. The GDD acts as a guide, keeping the project on track. It should include a summary of the game idea, the player's objectives, and a breakdown of the gameplay mechanics, such as controls and progression. Details about world design, visuals, sound, and monetization strategies like in-app purchases or ads should also be outlined. A well-structured GDD simplifies the development process and ensures clarity throughout the project. The next phase is prototyping, where ideas begin to take shape. At this stage, perfection is not the goal. Utilize Unity's built-in shapes, such as cubes, spheres, and capsules, instead of detailed models. Focus on testing core gameplay mechanics, like jumping, shooting, or double jumping. Implement player controls using Unity's input system. Prioritize quick iteration tests, small changes, evaluate what works, and make adjustments. The goal is to validate gameplay concepts effectively. With a working prototype, the next step is level design. Begin by blocking out the level using simple shapes to map out terrain, obstacles, and paths. This serves as a rough sketch of the game world. Once the layout is finalized, add gameplay elements such as platforms, enemies, and collectibles to shape the player's journey. Test the level's flow to ensure it feels natural and that objectives are clear. Once the design is refined, replace placeholder shapes with detailed assets and textures. Utilize Unity's prefabs to efficiently reuse objects across levels and streamline the process. Let's talk about assets. Assets are essential for bringing your game to life. If you create 3D models, tools like Blender are great. If not, the Unity Asset Store offers many pre-made models. Add textures to enhance visuals and import audio for sound effects and music. Use Unity's Animator controller to manage animations like walking, running, and jumping. Simply drag and drop your assets into Unity to bring your scene to life. Now comes the magic. Implementing game mechanics. Let's add some logic to your game. Create systems like health and damage for your characters, scoring mechanisms, or even enemy AI. For AI, Unity's nav mesh is fantastic for setting up pathfinding and patrol behaviors. Don't forget player progression. Whether it's leveling up or upgrading abilities, it's what keeps players hooked. Coding these mechanics may seem daunting, but start simple and build up. Once the game starts taking shape, it's time to test it. Playtesting is crucial. Explore every part of the game, take notes, and identify issues. Unity's console window helps track bugs. Collect feedback from friends or fellow developers, as they may spot things you missed. Use this feedback to adjust the balance of difficulty and rewards. Iteration is essential to refining and polishing the game. Optimize your game to avoid lag. Use Unity's profiler to identify performance issues, reduce draw calls with batching, compress assets, and use LOD groups for distant models. These tweaks ensure smooth gameplay, even on low-end devices. The final step is deployment. Open Unity's build settings, choose your target platform, and configure the resolution and quality settings. Test the game on real devices to catch any issues before finalizing. Once everything is ready, click Build, and your game will be prepared for release on platforms like Steam, Google Play, or the App Store. Even after launch, the work isn't over. Post-support is essential, including fixing bugs, releasing patches, and adding new levels or features to maintain player interest. Player feedback is valuable for improving the game, and engaging with the community helps build loyalty and shows that you care. That's your Unity game development workflow. Remember, each step is part of the learning process. Keep experimenting, stay curious, and enjoy bringing your ideas to life. Thanks for watching. Happy developing!